Hello, this is the first video of a Calculus 1 series on improper integrals for OCR Pure Core Further Mathematics, and it looks at integrals with infinite limits that are convergent. Improper integrals cannot be computed using normal integration. So an improper integral is a definite integral where we are attempting to evaluate an integral where at least one of the limits is infinite, or the function approaches infinity at some point in the interval required. Some integrals are convergent and some are divergent. Here is an example. F of x equals 1 over x squared. As you can see from the graph, although the function 1 over x squared tends to 0 as x tends to infinity, the area has infinite length, so we need to look at a limit. It is very difficult to tell at this stage whether or not there is a finite numerical answer. You can see that the integral we are interested in runs from x equals 2 to infinity. This is the technique we're going to use to try and tackle this. If we replace the upper infinite limit by a variable, let's call it a, let's see what happens in the limit as this new variable tends to infinity. We've still got our f of x, and we're still integrating with respect to dx. Well, we've got this limit as a tends to infinity, and 1 over x squared integrates to minus 1 over x, and we've got our new limits 2 and a. We're still looking at this in the limit of a tends to infinity. That we've put in those values there. So now consider, as a tends to infinity, this term 1 over a, or minus 1 over a, tends to 0. Hence, this limit here of this expression, the limit as a tends to infinity of minus 1 over a plus a half, will equal a half. Hence, we can say that this is the area under the graph. So this integral with an infinite limit is thus convergent, as it converges to this limit of a half. So here is a summary of the technique we've used. We've replaced the problem limit with a variable. We've called it a in this case. And we've looked at what happens in the limit as the variable tends to the problem value, in this case infinity. If there is a numerical answer, then the integral with infinite limit is said to be convergent. In the next video, we will look at integrals with infinite limits that are divergent.